Trick-free college, reference angles. All right, so before we get into this video really covers two major concepts in trigonometry. So let me just recap those for you. Our quadrants, or our graph, is split up into four quadrants. First quadrant's the top left, and then the second, and then the third, and then the fourth. So they go, starting in the top right, they go around the graph in a counterclockwise notion. So that's 4. IV is 4. And we have the acronym ASTC, which you learned last year, stands for All Students Take Calculus, is how we remember it, but it actually stands for that in quadrant 1, all the functions are positive. And quadrant 2, sine is positive, but cosine and tangent are negative. In quadrant 3, tangent's positive, where sine and cosine are negative. In quadrant 4, cosine is positive, but the others are negative. And this stems from the fact that, we're going to have, it might be the next video is the unit circle. And in the unit circle, we learn that x and y on a graph on the unit circle correspond to cosine and sine, where x is cosine, y is sine. We'll notice that in quadrant 1, all the coordinates in here are positive x, positive y, right? Like how I got to a point here is right and up, that's positive, positive. So because x and y are positive, cos and sine are positive. Well, in quadrant 2, I'd be going left to the negative side of the x-axis, and then I'd be going up, which is the positive for the y-axis, and so I'd have a negative x, positive y. Well, negative x means negative cos, positive y means positive sine, and so sine's positive, cos is negative. And tangent's also negative because a tangent is actually division of sine and cosine, so if you divide a positive and negative, you get negative. Now, in quadrant 3, you would go left and down. Left is negative on that axis, and down is negative on this axis, so negative, negative is negative x, negative y. So negative cosine, negative sine, but when you divide them, you get a positive tangent. Because remember, tangent is really sine divided by cosine. And so in quadrant 4, you'd be going to the right, positive, but down negative. And so positive x, negative y. And again, just think about any point over here. This would be like 5, negative 2, something like that. That's a positive x, so positive cosine, and a negative y, a negative sine. And so that's why cosine's positive here, but sine's negative. And again, because they're different, tangent's negative. Along with sine, cosine, and tangent, you also have the reciprocals. So the reciprocal of sine is cosecant. So cosecant's also positive here. Cotangent is also positive here, and secant is also positive here. So the reciprocal functions are the signs of the reciprocals, because reciprocaling a fraction doesn't change its sign. So if sine is positive, cosecant's positive. If sine's negative, cosecant's negative, and so on. And then the other thing this video is going to reference is what we call reference angles. Remember that in quadrant 1, the angles are between 0 and 90 degrees. And in quadrant 2, they're between 90 and 180. But a lot of times we like to reference them to an acute angle. So in quadrant 2, what we do is we always want to know how far are we from the x-axis, because that's how we draw triangles in here. And so remember that it's distance to 180 in actually both of these quadrants. So whenever we have a quadrant 2 angle, we can think of it as 180 minus that. How far are you from 180 is 180 minus that. Like if you're 100, 180 minus 100 is 80. And I'll talk more about this when we get to examples, but just remember quadrant 2, it's how short of 180 are you? In quadrant 3, it's how much over 180 are you? So it's your angle minus 180. Like 200 is in here, so 200 minus 180 is 20. And it's between 180 and 270. And in quadrant 4, we, again, want to know how far are we from the x-axis, but this is not only 0, it's also 360 when you're talking about the full circle. So in this quadrant, we're talking about how short of 360 are you, so 360 minus theta. But I'll talk about that when I get to an example specifically. All right, so this question wants to know what quadrant are we talking about. So sine is negative. So it's good to just kind of set up a little ASTC. So sine is negative. So that means we are not here or here because sine's positive in those spots. And tangent's positive. Well, tangent is positive here, but not here. So this must be quadrant 3. Let's do another. All students take calculus. You can be taking pre-calculus this year. Cosine is positive. That is not here, not here. It's in these two. Cosine's positive where all positive and C is positive. And cosecant negative, but for cosecant, I could just think about it as sine because it's the same sign as sine. So where is sine negative? Sine's negative here. Sine's positive here. It's negative there, so you're in quadrant 4. Which expression is equivalent to sine 200? So first of all, for these questions, you have to figure out, all right, what quadrant we're in. Now we're between 180 and 270, so you're in quadrant 3. And our ASTC tells us that in quadrant 3, sine is negative. So forget about these. Sine is definitely negative. But remember how we do. When we have an angle in quadrant 3, we like to turn our angles into triangles, and we always go to the x-axis. This is the reason why we want to know how far are we from the x-axis. And that's the point of having these reference angle formulas here. So how close are we to 180? And in this quadrant, 200, an angle of 200 is only 20 away from 180. This would be a 20-degree angle. So it's 20 degrees, and in quadrant 3, sine is negative, so the answer is A. And so when you have a question like this, you need to first ask yourself, where are you? It's like that real estate phrase, most important thing is location, location, location. So first determine the quadrant, and that'll determine whether or not you're positive or negative based on ASTC. And then from that quadrant, if you're in this one or this one, it's how short of 180 are you, or how much over 180, how far from 180 are you, and in this quadrant, it's how far from 360 are you. We don't really worry about reference angles in quadrant 1 because they're already acute, and that's the whole point, is making them acute. So let's do another example. Cotangent negative 120. First of all, I do not like negative angles. So the first thing I'm going to do is to make a negative angle positive, I can add 360 to it. So I could change that from negative 120 to positive 240. So just anytime you see a negative angle, add 360 to it, make it positive, make your life a little bit easier. Cotangent 240. Where is 240? 240 is also between 180 and 270. So we are in quadrant 3. Quadrant 3, A, S, T, C. Tangent and cotangent are positive. So I'm looking at a positive function for cotangent in quadrant 3. So get rid of anything with a negative sign. And how far is 240 from 180? 240 has a distance of 60 from 180, so the answer is cotangent 60. All right, and that's basically what we're going to practice the next day in class. See ya.